So anything you say may be on YouTube. Just like to give you a heads up. So we are looking at the end of 9-3. We're going to finish this today. Remember, we did our cards at the end of the day last class, so this should be the very end of the video before this. All of these were probabilities, so we had all of the possibilities, 52, choose 5 under everything, and then we just dealt with all of our possibilities based on the situations given. Remember, I gave you all of this stuff. I will not give this to you on the quiz, but I might ask you some card stuff. So know how many suits there are, know how many face cards there are, know how many colors there are. Little basic stuff. You guys can know it. You guys will be great. Okay, so we're going to get into some Venn diagram stuff. And I think Venn diagram, reading them at least is pretty simple. Building them is a little bit harder, but we're going to do both of those things today. So let's start by reading this Venn diagram. Okay, so it looks like I've got a circle with M&Ms. And I've got a circle with Twix, and they overlap in the middle. And it says that there are 30 kids in this class. So 30 kids responded to liking M&Ms or Twix or both. So how many like M&Ms?
17.
17. Why, Seth?
There's 11 already only like M&Ms, but then there's 6 more that like M&Ms.
Good. So only 11 like only M&Ms, but this whole circle that like M&Ms is 11 plus 6, which is 17. Now, that being said, how many like only M&Ms? 11. How many like M&Ms and Twix? 6. Like both of them would be 6 in the middle, right? What about how many like M&Ms or Twix? Where'd you get that? Ooh, I love that thought process, but
24?
I don't think I've heard it yet.
It's 26.
Why is it 26, Ava?
Oh, you add everything.
We have to add the M&Ms, the both, and the Twix. So if I like M&Ms or Twix, it doesn't. It only equals 26. Great point, Kelly. We're about to get there. So there are 30 people in that class, but only 26 are accounted for when we asked what kind of candies we liked. How many people like only M&Ms or only Twix? 20. There's a 20. So that one we do not include the middle number because I don't want the kids that like both. I only want the 20 that have a preference one way or the other. And then how many kids like neither candy? Where'd 4 come from? Good. So we had 30 kids total in the class, which is why we wanted to say 30 earlier, but only 26 voted. So that means 4 kids don't like M&Ms and they don't like Twix. You're part of those 4? What's your preferred candy, Callie? Oh, Mr. Goodbar. Huh. I do not like those that much. So. Oh, are we roasting kids in this class for candies? Does anyone like Almond Joys? I do not. You like Almond Joys? They're actually good?
They make you feel a little bit healthy because you eat some like protein with the almonds.
Okay. The almonds and the coconut have that much protein. Sure, we could break down the macros on that, and that would not be that much protein. All right, now we're going to build our own Venn diagram, and then we're going to go from there. So this one says each of the 28 students in the class either likes jazz music, country music, or both. Draw a Venn diagram showing the following. And we want to know at the very end of this, how many students like only jazz? Okay, so it tells me that 18 students like jazz and 14 students like country. How many votes do I have? How many people voted, or how many votes do I have? 32. Okay, how many kids did I have? 28. So what does that mean?
There's more people.
Some people voted twice. How many people voted twice? 4. 32 minus 28 would be 4. So there are 4 people who like both jazz and like country. They got voted twice. So that being said, how many kids like just jazz? 18 total like jazz, but 4 of them also like country. So how many is left? 14?
Wait, I'm here left.
Wait a second. Okay, backtrack. Inside this little box should be 18. So I already have 4 of them counted for. So how many more? 14. I'm still not convinced we're okay with that.
It makes sense.
I don't know, but we were really confused a minute ago. All right, let's do country then. So 14 kids like country. How many only like country? 10. Okay, there we go. I was really alarmed for a second. Now, how many is that all together? 28. Did any kid not vote? No, because at the very beginning it said each of the 28 students in the class either like jazz, country, or both. So that meant everybody's accountable. We normally write the number of kids that are not included or the number of votes that are not included out here, but I don't have any, so I don't need to write anything out there. Now, the overall question we were asked is how many students like only jazz, and how many is that? 14. All right, that's not bad. 2 circle Venn diagrams are pretty simple, right? That being said, we're going to jump up a level and we're going to do a 3 circle Venn diagram next.
My Lord's coming.
Yes, you knew it was too good to be true, right?
Yeah.
All right, I'm actually going to draw it down here today. We're going to draw it ourselves. I know, try your best. You're not getting points for how good your circle is. It says a class of 32 students is surveyed as to the type of car they like. 19 like Ford, 19 like Buick, and 12 like Chevy. 5 like all 3. 6 like only Ford, 3 like only Buick, 2 like only Chevy. Find the probability, blah, blah, blah. I don't care about that yet. Let's draw some circles. Yeah. Circle. I'm making mine a little oval. That's it. I need 3 of them. And they need to overlap. So I'm going to call this Ford, I'm going to call this Buick, and I'm going to call this Chevy. So now let's go back to the information that they gave us. Oh, what's happening? Okay, it said 19 like Fords, 19 like Buicks, and 12 like Chevys. I don't really know what to do with that number because if I start filling that in, that means in this entire circle should be 19 votes somewhere. And I don't know if it goes in here, in here, in here, or in here. So I don't know how to spread out those 19 votes, so I kind of have to wait a second. But it does say 5 like all 3. So let's go put 5 in the middle box. This box right here is in all 3 circles, so there are 5 kids that like all 3. Next, it tells me how many kids like only Fords. It says 6 like only Fords and 3 like only Buicks. Bless you. So I'm going to write 6 in the big box of the Ford, and I'm going to write 3 in the big part of the Buick. And then how many like only Chevy? 2. Thank you. 2 like only Chevy. Okay. Now, I don't know how to figure out what goes in these other little boxes. So what I need to do is I am going to put variables in there. Okay, I'm going to put an X for this one. I'm going to put a Y up here. And I'm going to put a Z over here. I'm using a variable to represent those spaces so that I can figure out what those spaces are. And what we're going to do now is we're going to write an equation for this. Okay, so the equation to represent how many kids like Fords is going to be 6 plus 5 plus X plus Y. Are you okay with that? Adding up all the pieces that make up my Ford circle. So 6 and 5 and X and Y are all in that Ford circle. So we'll say 6 plus 5 plus X plus Y. And how many kids did we say like Fords? 19. So we're going to say that equals 19. We're going to do the exact same thing with the Buicks. I'm going to do 3 plus 5 plus Y plus Z. So everything that's in that yellow circle, 3 plus 5 plus Y plus Z. And that also is 19 because 19 kids like Buicks as well. And the last I've got Chevy, 2 plus 5 plus X plus Z. 2 plus 5 plus X plus Z. And that equals 12. Everybody good with I've done what I have done so far? Okay, now we're going to simplify each of these equations. So it's just going to be X plus Y or X plus Z or Y plus Z on the left side, and then the right side is going to have all the numbers. So let's look. This first one, 6 plus 5 is 11, and then when I take 11 away from 19, I'm left with 8. So essentially, X plus Y equals 8. Next one, 3 plus 5 is 8. And so when I do 8 minus from 19, I get 11. So I've got Y plus Z equals 11. That's okay. We all heard you. And then the last one, I do 2 and 5, and that becomes 7. Minus from both sides, you get X plus Z. You good? Okay. Equals 7. So all I did was I just simplified my equation on the left to be my equations on the right. Is it 5, not 7? Is that why you all were looking at me crazy? Every so often I look out there and you guys look a little crazy back at me and I'm like, I must have messed something up. Oh. Jeez, we're falling apart. All right, so now what we want to do is we want to combine all three of these equations, and you have to pick one line that you're going to make everything negative. In order to cancel out, you're going to make everything negative in one of your equations, and we're going to combine them like a system. So I'm going to pick the middle line. I'm going to make Y and Z and 11 negative, and I'm going to add up my columns. Because that's going to cancel out Y and Z. So if I look at adding them up, so X and X are going to add up to be 2X. But positive Y and negative Y, those cancel out to be 0. And then negative Z plus positive Z also cancels out to be 0. So now I just have 2X equals a constant. 8 plus negative 11 is negative 3. Did I do that right?
Yes.
Yes. And then negative 3 plus 5 is 2. So 2X equals 2. I don't remember getting this answer last time. I have my X in a different spot than I did last time. Divide, X should equal 1. So I should have 1 in between Fords and Chevys.
What does the 1 represent?
1 is how many kids like both Fords and Chevys.
Oh,
Now we can figure out what my Y and Z are by plugging my X in. Yeah, I guess that's right. I just labeled my X in a weird spot this time. Okay. So say, don't make you what? All right, so now if I plug 1 in for X, I've got 1 plus something equals 8. What should Y be? 7. And then 1 plus Z equals 5. 4. So that means wherever my Y was becomes 7, and whatever my Z is becomes 4. Okay. That all being said, let's combine what we've got going on here. I want to know how many kids are accounted for now. So we're going to add all of these. 6 plus 7 plus 3 plus 1 plus 5 plus 4 plus 2. Add up all of these votes, and we need to see if there's anyone who didn't vote. So that's 10, 20, 28. So you guys get? So that means 4 people didn't vote, right? Because it was 32 minus 28. So 4 people didn't vote. Or 4 people don't like any of those cars. All right, that is important to note because now I'm going to go up here and I'm going to find the probability that if a student is chosen at random, he will fit in one of these categories. Can you remind me, what is probability again? How is that represented?
Oh, wait.
Success over total. It's always a fraction. So probability is the number of success over the total. So in this case, success is kids who like both Chevys and Buicks. So let's find where my Chevys and Buicks are. How many kids like both Chevys and Buicks? 4. I also want to include the kids that like all 3 because I would argue they like both Buicks and Chevys as well. So 5 plus 4 is going to be 9. So that is my number of success. 9 is my number of success. And how much is my total number of kids that I could choose from? How many did they tell us at the beginning of the problem? How many kids are there? 32. So 9 over 32 is my probability of getting a kid that likes both Chevys and Buicks. And if you like it as fraction, you can leave it as 9 over 32, or we can make it into a percentage, and that's about 28%. Okay. Anybody questions on that one so far? The next one says, what's the probability that the chosen at random likes none of the cars? Well, how many kids don't like any of these cars? 4. And how many total kids are there? 32. That's okay. So 4 over 32 is our probability of picking a kid that doesn't like any of those cards. That's about 1/8, which is about 13%. So again, I think building the Venn diagram is the hardest part, but then once it's built, we can do a pretty good job of solving and finding what's missing. All right, so now we're going to do the exact same thing with a new set of numbers, okay? So I just want to really solidify this in our heads. We're going to go down to the problem below it, and we're going to do the same thing with colors, okay? This time it says 68 seniors were asked if they like green, and 43 said yes. 23 said they like purple, 32 said they like yellow, 6 like all 3, 11 like only yellow, 15 like only green, and 4 like only purple. So let's stop, let's build ourselves a Venn diagram, and then we're gonna figure out what's the probability that a student picked at random will like at least one color. All right, so let's make your Venn diagram. Give me a box, give me 3 circles inside. Okay, put an arrow. I want an augmented matrix that is what you got when you did your REF. So whatever the calculator spit out for REF, I want you to write that somewhere too. If you draw arrows, I'll figure it out, as long as you feel like all your work there is shown. All right, I've got my circles drawn. I'm color coordinated. I'm ready to put some numbers in. 6 like all 3, 11 like only yellow, 15 like only green, and 4 like only purple. Okay, once I go here, now I'm ready to start finding what those missing boxes are. So you got to label them X, Y, and Z. If you do not have your shape set up like me, your X and Y might be a little bit different. So my X is between the green and the purple. Yours can be there too, or it can be somewhere else, that's fine. But know that if yours is not between the green and the purple like mine, you will not get the same answer for X as I do. Okay, so now I'm gonna write my equations. So I find the green ones, that's gonna be 15 plus 6 plus X plus Y equals, how many people like only green? Or how many people in general like green? 43. Okay. Then I'll do 11 plus 6 plus Y plus Z equals how many like yellow? 32. And then 4 plus 6 plus X plus Z equals 23. All right, simplify those. 15 plus 6 is 21 minus 21. X plus y equals 22.
It's so big, the numbers.
Because we've surveyed a lot more people.
68.
11 plus 6 is 17. So minus that from 32 and I get 15. And then that's 10, so that'll be 13. And yeah, the numbers are much bigger this round, but it's just because we have more people. We could have giant numbers. It's just what's given to us. What do I do now? Good. Make one of them negative. I like my second equation because that gives me x first. And then I'm going to combine them all. So I'm adding all of those up. X plus x is going to be 2x. The y's cancel, the z's cancel. And I believe I get 10? 20? 20. Because that's 35 minus 15 is 20. Okay, yeah, I'm okay with that. But now when I divide x equals 10. All right, so I'm gonna go plug x in for 10, put it on my picture, plug it into my equation. So 10 plus something equals 22, so y must be 12. And then 10 plus something equals 13, so z must be 3. Okay. Before I do anything else, I gotta figure out, are there any kids that didn't get counted? So count up all the numbers that we have right here and decide, did anybody not get counted? So 10, 20, 20 plus 30 is 50. 50 plus 11 is 61. All right, I think we have 61 accounted for. Do you guys okay with that? Remember, I just add that I add up all the numbers I see and I get 61. So if there were 68 people surveyed, how many people did not vote? 7. Okay. Now I'm ready to do my probability. It says if one student is chosen at random, what is the probability that he will like at least one color? So we've got a couple options here. One, you can think about all the students who like any color, which essentially we just added up a minute ago, 61. That number divided by how many students there are, just 68. That's the probability we will like at least one color. Now, another thing you could do is think about, okay, how many kids don't like any of these colors? 7. So I can think of 1 minus my probability that somebody likes no colors and minus those off. So 7 over 68. 1 minus 7 over 68 is the same thing as 61 over 68. Either way is fine. It was pretty easy to add up all my numbers and decide that it was 61, but sometimes it's not that easy, so I like having the shortcut just in case I need to use it. Okay, questions, thoughts, comments? I added 15 and, ooh, that's not what I want to do. 15 and 12 and 11 and 6 and 10 and 3 and 4. And add all those pieces up. Okay. And if we put that in the calculator, can someone do 61 divided by 68? About 90%. Perfect. Okay. All right, stay with me. We're skipping the next page, so you can just keep rolling past that. And we are going to end today with 3 probability trees. Probability trees will most likely be on your quiz tomorrow or on next class. I'm just going to keep saying tomorrow. I know you're not taking it tomorrow. Probability trees. I believe you've done something like this before. If not, it's pretty simple, but it's a very like specific skill, so I like to kind of go over those together. It says if it rains tomorrow, the probability that Joe will do his homework is 40%. Okay, so we're talking about whether or not it's going to rain and whether or not Joe will do his homework. What's my deciding factor? Is it if he does his homework, then it will or won't rain, or is it if it rains, then he will or won't do his homework? If it rains. So the first thing that matters is the rain. So I'm going to draw kind of like a sideways tree. I'm going to draw a little arrow up and down. I'm going to rate rain and no rain. And no matter what the weather decides to do, he has the option to do his homework or to not do his homework. So for rain, I've got a branch that goes to homework and not homework. And for no rain, I've got a branch that goes from homework to not homework. On those branches, we're going to write the probability that that will happen. So the first one is, if it rains tomorrow, the probability that Joe will do his homework is 40%. So I'm going to follow the branch from, okay, it's going to rain, and then percent that he's going to do his homework. So I'm going to write 40% right here as a decimal. On the line that connects rain to homework, I'm going to write 40%. So that being said, what's the percent or what's the probability that he will not do his homework if it rains? 60%, 0.6. All right, then it says if it does not rain, the probability of him doing his homework is 10%. So I'm going to follow the not rain and go to the homework, and that is 0.1, 10%. Now, what's the probability of him not doing his homework if it doesn't rain? Yep, 90 or 0.9. That's not a good percentage. I think Joe's a second semester senior. Given the probability that rain today is 30%, find Joe's probability of doing homework. Why did they need to tell me the probability of rain was 30%? Where does that go? The top one right here, 30%. So what's the probability it won't rain? 70. Okay. Now, we want to find the probability of him doing his homework. So there are two situations where he would do his homework. One is that it rains and he does his homework. Or what could happen is it does not rain and he does his homework. So two situations. Since I said that it could rain and he can do his homework, we're going to do what to those two numbers? What do we do when we hear and? In probability, when we hear and, we're going to multiply them. We're going to multiply them. So I'm going to do 0.3 times 0.4. And that gives me about a 0.12, 0.12. All right. Or the second thing that could happen is it's going to not rain and he will do his homework. So we will multiply those two together because those could both happen. And these are two separate possibilities of what could happen. In order to find the probability of any of it happening, we need to add those two numbers together. So I'm going to do 0.12 plus 0.07, which is 0.19, or 19%. That's not bad, is it? Yep. Let's do two more. Then we're done for today. All right, next one says, it's talking about cafeteria. It says if the cafeteria serves noodles, there's an 80% chance that they'll serve a salad. If they don't serve noodles, there's just 50% chance they'll serve a salad. All right, pause. Which should go first? Should noodles go first or salad go first? Noodles, because it says if we serve noodles, so I'm going to say noodles goes first. Isn't noodle such a weird word? Do you ever say a word so many times that you like make it sound weird in your head and in your mouth? I've said noodles like 7 times today, and I'm like, that just can't be it, is it?
Wednesday.
Wednesday, yeah. Wednesday. There's a weird word the other day that's like very normal that I say a lot, and I just like got it all messed up in my brain. I go, that can't be it. And it is. I don't remember what it was. So for both noodles and no noodles, I'm going to have the option to have a salad and no salad. Okay, once you have your probability tree made, we got to add some probabilities to our tree. It says if they serve noodles, there's an 80% chance they'll serve salad. So where does 80% go? On the very, very top. Between noodles and salad, 0.8. So if we have noodles, what's the probability we will not have salad? 20, good. 20%. Similarly, if there are no noodles, it's just 50% chance they'll serve salad. 50-50, 5-5, 0.5, 0.5. All right, now it didn't give us a number on what's the probability of serving noodles, but it says, given they serve noodles just once each week, what's the probability they will serve salad? They serve 1 day pasta out of how many days? 5. We only go to school 5 days, so we'll say 1 out of 5, which is about a 0.2. So noodles is 0.2, which makes no noodles 0.8. Okay. So now it says find the probability that we will serve a salad. So we have to go, okay, yes noodles, yes salad, and we have to go no noodles, yes salad. So 0.2 times 0.8 is 0.16, and then 0.8 times 0.5 is 0.4. And what do I do with those two things? Add those together. So 0.56, which is about 56%. All right, last problem for today. Everybody ready? Last problem. Oh, this is fun. It's about a student that plays lacrosse if he or she plays soccer. So it says the probability that a student plays lacrosse if he plays soccer is 62%. Which one is the determining one? We're going to put soccer first. So because it says if they play soccer, then the probability they play lacrosse is 62%. So we're going to do soccer and no soccer first. Then we'll do lax and no lax second. Lax and no lax. Okay, so it says if he plays soccer, the probability that that student plays lacrosse is 62%. So where does 62 go? On the top, between lax and soccer. So what's the probability if they play soccer, then they won't play lax? 38. Okay. Then it says the probability that he plays lax if he doesn't play soccer is 48. So no, oh, I didn't label that. No soccer. No soccer and yes lax is 48%. So what's no soccer, no lax? 52. The final sentence is the probability of student playing soccer is 70%. Find the probability of that student playing lacrosse. So 7 is going to be how much percentage we play soccer. How much is no soccer? 0.3. And so now we're going to multiply. We're going to do 0.7 and 0.662 in order to find out them playing lacrosse. And I'm going to do no soccer and yes lax. So 0.3 times 0.48. Okay. 0.3 times 0.48. So we got 0.144. Okay. And then we're going to add them up. And I think that's about 0.578. And I'm just going to round that up to about 58%. So in this situation, it's about 58%. You're going to choose a kid at random that plays lax. All right. I do want you to do the first 9.3 homework for tomorrow, okay? First 9.3 homework, I want that done for next class. Just because I want us to practice. There's a lot of things I could ask you on this quiz, but remember, these quizzes aren't very long because it's only 15 points. So make sure that you study. I think I have office hours tomorrow. Actually, let me email you or put it on Schoology if I do have office hours. I might have a meeting or something, so we'll just kind of hold that out. 9.3 homework number 1, due next class.
Number 1.